Hello everyone, in this video I want to show you how to convert a negative number to its binary representation, assuming that we're going to use the 2's complement technique. So the idea is very similar to when you want to convert an unsigned integer to its binary representation. I'm just going to explain how it works. It just basically the same as the previous video, but in this case we have an extra step. Let me explain it with an example. Let's say the number that you want to convert to its binary representation is negative 65,000, and the idea is similar to the previous video. You need to first divide this number by 2 many times until you reach to a quotient equal to 0. And the only difference here is you need to get the absolute value first because the number is negative. So you need to get the absolute value to convert negative 65,000 to 65,000, then divide it by 2, get the quotient, place it in B2, get the remainder, place it in C2, and then do the same thing for the rest, of the rows. You know, again, the number is 32,500 from the previous row. I place it in A3, then I divide it by 2 and put the quotient in B3, put the remainder in C3, and do the same thing again and again and again until I reach to quotient 0 in row 17, as you see. But because I want to do all the calculation with 32 bits, then therefore I continued all the way to this row. But you know, when you do that, that's going to basically add a bunch of ones at a bunch of leading ones at the end, which is not a big deal. So after I calculated column C, I will have a bunch of zeros and ones. Then I reverse the order of column C and I place it in column D, kind of similar to what I did for converting an unsigned integer to binary representations. However, here I have one extra step. I need to do a bitwise complement operation on column D and write it in column E. So that means I have to flip the bits in column D and write it in column C and column E. That means 0 becomes 1, 1 becomes 0, 0 becomes 1, 1 becomes 0, so on and so forth. And then I concatenate all the bits in column E and I write it in cell F2, and that's my 2's complement representation minus 1. What does minus 1 mean? That means if you want to get the correct 2's complement value or 2's complement representation for 65,000, what you can do is just add this number by 1. So if I add it by 1, I get basically the same number. Just gonna look this way. But when I add this number by 1, the last 4 bits will change from 0, 1, 1, 1 to 1, 0, 0, 0. Add a number by 1, that's what you get. Yeah. Before that, I need to go format and I need to do it this way. All right, this is now 1, 0, 0, 0. Perfect. What happened to this? Yeah, this one is going to give me a hard time because of the formatting. Let's make it text and try again. 1, 0, 0, 0. Yeah, that's good. So this one is the binary representation of negative 65,000. let me unfill this. So what I'm going to do is I'm going to place it here, and I'm going to say this is the 2's complement after adding it by 1. So basically, I did everything automatically using Excel, except the very last step when I added the number by 1. And that's how you convert a number to its 2's complement representation, the negative number to its 2's complement representation. If the number is positive, then you don't need to do anything special. But for negative number, the 2's complement representation has to be done this way. If you want to do a sign magnitude representation for a negative number, that would be 10 times easier than this. All you need to do is to find the binary representation of its absolute value. That would be called the magnitude. And then depending on the sign, if the sign is negative, you need to add a 1 to the very leftmost position of the number. If it's positive, then you need to add a 0 to the leftmost position of the number, or to the leftmost digit of the number. And that would be it. That's the sign magnitude representation. For 2's complement, you need to basically do this operation that I explained. Thank you.